Hey guys, it's Mr. C, and in this video, I'm going to show you how to perform sequences of transformations to write a new function. And all of the functions that I'm going to be looking at are going to be parent functions at the very beginning. And in another video, I will have functions that are not parent functions. But in this one, it's kind of an introductory video on sequences of transformations. And so I'll be pulling in a lot of the concepts and talk and vocabulary from the previous videos on transforming functions and translating functions, and we're going to kind of put it all together. So in this one right here, we're going to start out with a function f of x is equal to x squared, and so that is our basic quadratic function. If you haven't gotten to this in your lessons yet, don't worry about it. I'll show you a picture on Desmos of what this looks like, and I'll be using Desmos to verify all of my answers just to make sure that I'm correct, which is what a student should be doing, anyway, just to make sure that they've got everything, correct for each step. So we start out with x squared, and we're going to transform it using the sequence of transformations below to form the new function g of x, write the new function. So all of my question stems are going to look just like this, except I will change the parent function up from time to time, just so you're exposed to the other parent functions and how the graphs look. So we're going to move this. First of all, it says 1 unit to the left. Now, the thing is can I do these out of order? Well, sometimes and sometimes not. I would recommend not doing these out of order unless you know exactly what you're doing and you know when these can be switched and when they can't be switched. Sometimes they're commutative, which means you can do one before the other, and sometimes they are not. So until you get enough experience, I would just do them in order 1, 2, and 3, and then later on I'll have a fourth one down here. So I won't go over 4 because then it starts to just get over the top and a little bit too confusing. So let's move this 1 unit to the left. So we're going to take the x squared, and we don't have parentheses around the x, so we have to make them. So x, and when we move to the left, we remember that it's not subtraction, it's addition to the x. And so we're going to add 1 inside the parentheses, just like our instructions said on our notes and our graphic organizers that we used in the other videos. So squared, and that should do it for 1 unit to the left. Now let's go 2 units down. And so like we learned before, we just take our function, x plus 1 squared, and then we're just going to subtract 2 at the end. And that should move it 2 units down. Then finally, we're going to reflect it across the y-axis. And so to do that, we remember that we replace every x with negative x. So we have negative x plus 1 squared minus 2. Okay, so my hypothesis is going to be that function for g of x. And I don't know yet if that's going to be correct, but we're going to check it using Desmos. Desmos is, again, a free app on Android and Apple products that I would highly recommend that you get. I would have loved to have had this in college, but I had a TI-83 calculator, and this right here, for graphing purposes, completely replaced my TI-83 as soon as I found this free app right here. So now I use Desmos all the time. And so that is DESMOS, in case some of you guys do not have that yet. You want to have that. All right, so first of all, we're going to start with our parent function, x squared, and there's our parabola we see. And we're going to move it 1 unit to the left, so parenthesis, x plus 1, and then it's going to do stuff like this until you get the whole thing in there, squared, and we do see that it moved it 1 unit to the left. Okay, so let's get rid of that first one. Then we're going to move it 2 units down, so x plus 1, close parentheses, squared, and then we're going to subtract 2 at the end, and we see that it did in fact move 2 units down. Get rid of that one. Okay, now we're going to reflect across the y-axis, and so, like we said, negative x plus 1, close it up, squared, and then still minus 2, and we see that it did reflect it across the y-axis, and there is our new parabola, and then that's the final one. So using Desmos, then we verified that all of our steps are correct, and now we can go ahead and officially write g of x is equal to negative x plus 1 squared minus 2, and we would expect to get full credit from that. All right, next one. Okay, this one, we have our linear function, just f of x equal to x, and we want to first reflect it across the y-axis again. So we remember we just take the x and replace it with negative x. I don't need parentheses because that's the only thing there, and parentheses aren't really going to do me any good anyway when there's only one thing there. So now we're going to move it 3 units up. So that means we need to add 3 units to the end. So all of our y values are going to be moved 3 units up. And then finally we have 5 more units up, which seems kind of weird, but you know, if you think about it, if you're playing a video game and you move your character 3 units up and then you move it 5 more units up using the joystick, this is how the computer or the ICU is, not ICU, the CPU, ICU, too much TV. The CPU is handling this with its input, and you're actually taking negative x plus 3 and adding 5 more to that. I can't believe I said ICU. Oh, well, I'm going crazy. All right, now this can be simplified into negative x plus 8 for my final hypothesis to see if that's correct. And by the way, I always check my work, and I'm a math teacher, and I always check my work because you know what? I make mistakes just like everybody else, and I've made more mistakes than students are ever going to make in their life. And so I've learned to just check my work. So let's start with x. There it is. There's our line, our identity function. Okay, let's reflect it across the y-axis. So negative x. Okay, did that happen? Yep, it got reflected across the y-axis. So get rid of that. Okay, so now let's add 3 to move it 3 units up. So negative x plus 3, and it does in fact move it 3 units up, definitely. Okay, let's get rid of that one. And now we got negative x plus 3, and then we're going to move it 5 more units up plus 5. And we see that it moves it 5 more units up. So now let's get rid of that one. My simplified answer was negative x plus 8. And just to be clear, it's the exact same line when I graph it. It's because it turned from blue to black. So the exact same line. So now I know I'm good. Get rid of those. And now I can officially write g of x equals negative x plus 8. If you don't have a device like an iPhone or an Android, Desmos, if you just Google it, it's a free internet. It's not an app, it's just an interface. And so you can use that on the computer all you want. The input's a little bit different than my iPad, but it's basically all the functionality is the same. Highly recommend bookmarking that on your computer if you have a computer. All right, so let's look at this one. Now we have an absolute value function, and we're going to reflect it across the x-axis. So like we did before, you just make each term negative. And so there's only one term to begin with. In other videos, I'll have more terms, so I'll show you how to do that. But in this one, it's just absolute value, just make it negative. Okay, now we want 2 units to the left, so negative. Now to move it 2 units to the left, we have to add 2 inside the parentheses. So are these parentheses? Well, they are grouping symbols. Absolute value function is a grouping symbol, and it does more than just make negatives positives. It actually confines the x plus 2 in here, so I don't need an extra set of parentheses in there. That should work just fine. 2 units to the left. Okay, now finally I want a vertical stretch of factor 4. So vertical stretch says to multiply the function times this number right here. So I'm thinking negative 4 absolute value x plus 2. Okay, so why didn't I distribute that 4 to everything in here? Why didn't I just distribute the 4 to the x? Because the instructions say to multiply the function times the 4. The function is this, and this is my grouping symbols. I do not want to distribute, because if I do that, I'm going to probably lose that negative right there. So be very careful. So that's my hypothesis, and let's check it out and see if it actually works. So first thing, we want absolute value of x, and go back and do that again. Absolute value of x, and there it is. Okay, so now let's take that and let's put a negative in front, see what happens. And it definitely does reflect it across the x-axis. Okay, so now get rid of the first one. Okay, 2 units to the left. So now we want negative absolute value, and I think we said x plus 2. Okay, and it did move it 2 units to the left, just like I wanted. Get rid of that one. Vertical stretch factor 4. So negative 4 absolute value, x plus 2. Okay, and vertical stretch says, and it did say, yeah, vertical stretch. For a vertical stretch, the points are being pulled vertically away from the x-axis, and they are being pulled away from the x-axis vertically, and it's making it narrower right there. So that works. Everything looks good. We'll get rid of those. And now we'll go ahead and write our final answer as g of x equals negative 4, and then x plus 2. Okay, and we should have full confidence in that answer right there. All right, let's check out this one. Okay, this one again, absolute value. So let's start out with a horizontal stretch of factor 1/2. Horizontal stretch, if you remember, we're going to replace every x with ax, where a is a proper fraction. And so we're going to write simply 1/2 x. We take the x out, replace it with 1/2 x. Okay? Reflect across the y-axis. Now this one's interesting. If I reflect it across the y-axis, I'm supposed to take the x and make it negative x. So if I do that, I'm going to get something like this. Now, interestingly, that negative right there can come out in front, and I could actually write negative 1/2 x like that. However, it is absolute value, and that negative as an absolute value is going to turn into a positive and go away. The reason why is because my original function is on the y-axis, the vertex. And since it's on the y-axis as a vertex, when I flip it, and let's go ahead and just use these 2 markers as an example. If I'm on the y-axis right here and I flip it, that's what's going to happen. The left side becomes the right side, and the right side becomes the left side. So nothing is really going to change there. And the only time that's going to change is if you actually move it left or right first before you do this. And this is why we need to do these in order, because this time it's not going to make a difference, but in another problem, it probably will. So we just need to be careful there. And then we want 3 units up. So to move it 3 units up, we're going to take that negative 1/2 x, and then we're going to add 3 to that. Now I'm going to make a hypothesis here also. I'm going to make another hypothesis that says that this function, positive 1/2 x, absolute value plus 3, is going to give me the same graph. That's my hypothesis. And the reason why I'm making that hypothesis is because of what I said up here, that when I flipped it up there, it really didn't change it. So I'm going to hypothesize that these 2 functions are the same. So we're going to check that here using Desmos just to be sure I'm right. Okay, so let's take our absolute value of x. There it is. Okay, here's our horizontal stretch, factor of 1/2. So we're going to do 1/2, 1 divided by 2, arrow over x. Okay, so for a horizontal stretch, it says the points are being pulled horizontally away from the y-axis. And is that true? That is true. It got pulled down like this, and they're being pulled away from the y-axis. All right? Now we're going to reflect that across the y-axis. So when we do that, we've got 1/2, 1 divided by 2. Okay, then we got our x. But it's really, in parentheses, negative x. Remember how we wrote that? And then there's our function. And it's the same exact one. It turned from red into, looks like blue right there. If I take that and I move that negative, let's say I move that negative out front. Okay, and then I take it away here. So let's take it away here. Okay, and I get the same thing, don't I? I'm going to leave it there for a minute. Okay, and I'm now going to move it 3 units up. Let me get rid of all of this stuff right here. Okay, I'm going to move it 3 units up now. So absolute value, and I'm gonna keep the negative in there just for now, negative 1/2, arrow over, x, arrow over again, and then plus 3, and we see it does move 3 units up. Now I'm gonna test my hypothesis. So I know that this one's correct, so I'm gonna test my hypothesis, arrow over, I'm gonna back up, and I see clearly now that my graph did not change. So my hypothesis of this one is correct. So either of these two answers, if a student gives me either one of these, I would be okay with that. As a matter of fact, there's actually another answer that's okay. Let's suppose I take that 1/2 and I pull it out. I go ahead and just remove it all together. All right, so watch this. I'm gonna go out front and I'm gonna put my 1/2 out front. The same graph. This is because for an absolute value, if you have a coefficient in front of just that x right there, you can pull it out of the absolute value and it does not change. So that's a property that you're going to become familiar with as you study absolute value functions. All right, not other functions generally don't do that, but absolute value does. Okay, sometimes you just have to be kind of careful with that, especially with quadratics and so on. But absolute value will work that way. So there's actually 3 different answers that I could have put down for this one, and I could have still been correct. So if a student says, hey, I got this, I'm okay with that. If a student says, I got this, I'm okay with that. Then if a student said, you know what, I decided to pull the 1/2 out because I know how absolute value works, I'm okay with that now too. Actually, I'm doubly okay with that because that's good knowledge. All right, so now the most common answer I would see from students who are following directions is simply going to be negative 1/2 x, just like that, absolute value, and then plus 3. But I would be okay with any one of these. And I know it may be confusing, but in mathematics, the sooner you get a handle on when things are actually equivalent, the better, because it's going to happen all the time with stuff like that. Doesn't mean you're wrong. It just means that there are other ways to write something, and mathematically, there's a perfectly good, valid explanation for that, and it does work. All right, so now let's step things up a little bit. Okay, so now we're going to go ahead and put 4 things on there. So I got to be real careful now. Okay, so we have square root function, 3 units down. So square root of x minus 3 at the end. Definitely don't want to put it underneath the square root. So square root of x minus 3 at the end. Okay, reflect across the y-axis. All right, so take each x, replace it with negative x. Still minus 3 at the end. Can you take that negative out? No. Leave it right there. Don't start playing around with this. Just leave it like this. Okay, 9 units to the right. Okay, 9 units to the right. If we're going this way, we have to subtract. Remember, it's opposite. So square root of negative x minus 9. And then minus 3 at the end. Okay, and we're going to check all these, by the way, too. And then vertical compression of factor 1/3. So vertical compression, we're going to multiply the function by a factor of 1/3 for the vertical compression, right? So multiply the function by a number between 0 and 1, the whole thing. So what we're going to do is we're going to take 1/3 of this whole thing, negative x minus 9 minus 3. Okay, so let's be very careful here. When we multiply this whole thing by 1/3, we're actually going to get 1/3 of negative x minus 9, and then 1/3 of negative 3 also. So minus 1. So I'm going to claim, by following instructions, I'm going to claim that this is my final answer here. And so let's see what that looks like on Desmos. All right, so first thing we need is square root of x. And there it is. There's your square root function. Okay, then, let's see if I can get all of this in the shot here. Okay, then we're going to move it 3 units down. So square root of x, arrow over, minus 3. Okay, so it moves it 3 units down. Okay, get rid of that one. Okay, now we want to reflect across the y-axis. So square root of negative x. Okay, arrow over, and then minus 3. Okay, so it does reflect it across the y-axis. So get rid of that one. Okay, 9 units to the, and it did say right, So now we want 9 units to the right. So here we go, negative x, and then we said minus 9, arrow over, then minus 3. Okay, so did it move it 9 units to the right? So what happened was now, 9 units to the right, we have negative x minus 9 and then minus 3. So there's my work and there's Desmos. So did it move it 9 units to the right? Okay, so it moved it 9 units to the left, didn't it? Okay, that's going to be a problem. Since it moved it 9 units to the left, I know now that when I subtracted that from the x, I subtracted it from the x right here, this negative x. I've got to be really careful with that because what I needed to do is the opposite. So if I go back here and I write a plus right there, okay, now it actually goes 9 units to the right. So why is that? The reason why that messed up there was because you had a negative x there and not a positive x. And so what it should have been was this. So let me go up here. This happens all the time. So when it says negative x and it says subtract 9 units from the x, what I should have done was negative x minus 9 in parentheses, because that would have made it negative x plus 9, which is now correct. So what do I need to do now? See, this kind of mistake happens all the time. So now I just need to fix this, and I need to go down here and I need to fix these. Okay? All right. And we can't do everything perfect by the book every time, because if we do that, then you never see how these mistakes are made and then you get confused. So this type of a situation is perfect. This is exactly what happens when people, do these sequences of transformations. All right, back on track now. Now that we got that fixed and explained, now let's go ahead and do a vertical compression. So now we need to get rid of that guy. All right, so now we're multiplying everything by 1/3. All right, so here we go. So we got 1/3, 1 divided by 3, arrow over, square root. Okay, so that was negative x plus 9. So we fix that. Okay, and then minus 1 now. Okay, so for our vertical compression, here's what it says. It says the points are being pushed vertically toward the x-axis. Have the points been pushed vertically toward the x-axis from here to here? And the answer is yes. Even the point where it started got pushed. So the whole thing got pushed toward the x-axis, right? And if you look at the ends of it, you can see the thing being twisted towards the x-axis, and that's exactly what's supposed to happen. So most common mistake here is not only this one that I see people do all the time like that, it's also here, because people will forget to distribute that 1/3 to both of these terms, and they'll only do it to that one right there. So this is an excellent example that's well worked out, and you might want to watch it a couple times and use Desmos just to kind of clear your head and see that what's happening is what's supposed to be happening. Or it can get really confusing to students that look at this and say, I looked at it one time and then I'm done with it. Then they take a test and they make a 20 on it. And then that's the whole reason why. They haven't completely understood each one of these steps and why the algebra is working out the way it is in relation to the graph, what the graph is supposed to look like. So again, always use a graph when you're doing these if you can to check your work, and then you won't make those mistakes later on a test. All right, so let's get rid of those guys. Okay, and hopefully the next one won't be as bad, but you never know. They usually are. Okay, so this one we have x squared, and our first step is a horizontal compression of factor 3. So horizontal compression is you replace every x with ax where a is greater than 1. So we're going to take that x and then we're going to replace it with 3x. Okay, so watch this. So if I put 3x here squared, I'm in trouble. And the reason why I'm in trouble is because, yes, I replaced the x with 3x, but I've got to use these parentheses because it's not just 3x squared on the outside, it's actually going to be 9x squared. Okay? I didn't want to let that one go because that's the first step, and I don't want to have to go all the way back to the first step and then make corrections all the way, from here on down. So let's just deal with this now. The most common mistake right here is not using parentheses. All right, now we got to do a reflection across the x-axis. Now that one shouldn't be too bad. That one you just put a negative in front of all the terms, and we only have one term, so negative 9x squared should do it. All right, 1 unit down, simple enough. We just take the negative 9x squared and we just move it down 1 unit, no problem. 5 units to the left. Okay, we're gonna have to, 5 units to the left, we're gonna have to add 5 inside parentheses. So negative 9, then parentheses, x plus 5 squared, and then minus 1 at the end. Okay, so my hypothesis is that last expression. I'm gonna write it over here so I can see it on Desmos when I put my iPad down. Okay, so now let's take a look and see what this looks like. All right, here we go. Let's home this. Okay, so let's start with x squared. All right, now horizontal compression factor of 3. So we said that was 9x squared when we got done. Okay, horizontal compression. The points are being pushed horizontally toward the y-axis. Clearly, that's what's happening. They're being pushed horizontally toward the y-axis. Okay, so we'll get rid of that. Okay, reflection about the x-axis. So negative 9x squared, and it did reflect. There it is right there. So get rid of that one. Okay, 1 unit down, negative 9x squared, and then minus 1. Okay, it moves it 1 unit down. So we're good there. And then we want 5 units to the left. So negative 9, parenthesis, x plus 5, parenthesis, squared, and then still minus 1. And we have the same exact graph. You can clearly see it, and it's been moved 5 units to the left. So I'm very confident in that answer. That looks very good. Not as bad as the last one, thankfully. So this one, we'll put g of x equals, and then negative 9, x plus 5 squared, and then minus 1, and we should get full credit for that. All right, guys, wish it was easier, but it is what it is. Remember to keep those notes handy for your graphic organizers, for your stretches, compressions, and then your translations and transformations. And so hopefully this will help. Let me know if you need a few more videos of this, because students really struggle with this stuff right here. I've taught this many years, and every year it's a struggle. So I get it. Remember to like and share. Subscribe to my channel if you haven't already, and we will see you guys later. Bye.